Students, do you remember one of your favorite songs of all time? Oh, sometimes I graph a linear equation. Yeah. Y equals mx plus b. M is the slope. B is the y-intercept. Oh, yeah. Graph a linear equation. Yeah. Well, we're going to use that knowledge to help us graph linear inequalities. They are really similar to the last ones, except instead of an equal sign, we will have an inequality. For example, a less than or equals to sign, greater than or equals to sign, a less than sign, or a greater than sign. We'll learn that the rules are very, very similar. So let's take a look at one particular example. Y is less than or equal to negative 2x plus 4. We will begin by graphing exactly as we used to. The y-intercept is 4 and the slope is negative 2. That part does not change. Let's come over here. The y-intercept is 4. Up 1, 2, 3, 4. The slope is negative 2. We go down 1, 2 over 1. 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 Now, because this is a less than or equals to sign, we will draw a straight line through the points. If this were a less than or greater than sign, we would draw a dashed line through the points. So let's just go ahead and draw a straight line through it because this particular problem is y is less than or equals to. Okay, excellent. All right, we know it goes off in every direction, north and south. The y-intercept was 4 and the slope was negative 2. There's one last thing we have to do. This says y is less than or equals to. Less than. Less than means that any solution less than or under this line is going to be true. So what we actually get to do is go back to kindergarten and color. We'll just shade under this line because it said less than. If it had said greater than, we'd shade above the line. And the reason is because if we pick any point in this solution region, it will be true. Let's take an example. Let's take negative 1, 2, this point right here, which is negative 2, comma 0. It is in the solution region, so if we put negative 2, comma 0 into our inequality over on the other board, we should get a true statement. Let's give it a shot. Our solution, we said, should be negative 2, comma 0. That should come out with a true statement. So for y, I will input 0, because this is x and this is y. 0 is less than or equal to negative 2 times, was the x coordinate? Negative 2 plus 4. 0 is less than or equal to negative 2 times negative 2 is positive 4. 4 plus 4 is 8. 0 is less than or equal to 8. That's pretty cool. We could have chosen any ordered pair within that solution region, and it would have been true as well. Let's look at one more example. Okay. 5x minus 10y is less than 20. Well, this isn't in that y equals mx plus b format, but we know how to change that pretty easily. First step is to eliminate x. So we'll put our upside down t, so we're fair. We subtract 5x from both sides. 5x minus 5x, well, that's nothing. It goes right away. Now we'll drop down the negative 10y because we hadn't done any operations to that yet. 20 minus 5x. And now we divide both sides by negative 10 because negative 10 is the coefficient. The coefficient is multiplication. To isolate for a variable, we must do the opposite operation. So we divide by negative 10. We divide by negative 10, and to be fair, we must do it to everybody. Everybody gets divided by negative 10. Now let's think back. Solving inequalities. When we multiply or divide both sides by a negative number, oh, we get to exercise, right? Look what we did. We divided both sides by a negative number, which means we're going to need to reverse the inequality sign. Negative 10 divided by negative 10, well, that cancels itself out to 1. We need to reverse this inequality sign because we divided by a negative number. 20 divided by negative 10 is negative 2. And negative 5 divided by negative 10, negative divided by negative is a positive. So that's plus, well, 5/10 is just a half x. All right. So now we have our linear inequality in a format that we could graph. So let's graph it. Y is greater than negative 2 plus 1x over 2. I'll go ahead and write that up here. Y is greater than negative 2 plus 1x over 2. Okay. All right. So we've got that here. I'll go ahead and erase these stray marks. So our y-intercept in this case is negative 2. So we'll go down 2 spaces. Our slope is up 1 over 2. 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 Now we can draw a straight line through this one. Do you remember the rule? If it's less than or equal to, or greater than or equal to, we draw a straight line. But if it's just less than or greater than, we draw a dashed line. So actually, we aren't going to draw a straight line through this. We're going to draw a dotted line through it. Okay. That's how we know that it is less than or greater than. Now, in this case, it says y is greater than negative 2 plus 1x over 2. So when it's greater than, we get to shade up. When it's greater than, I mean, when you wake up in the morning and you say, I feel great, you lift your hands up. You don't say, oh, I just woke up and I feel great. No, you always lift your hands up when you feel great. So greater than means you shade above the line. So this solution region, we could pick any number in this solution region and it would be true in this graph. In this case, let's just choose the easiest one. The origin is in the solution region. The origin's super simple, 0, 0. Let's see if 0, 0 works with the original equation. Excuse me, the original inequality. 0, 0. Well, let's input 0, 0 as x and y. 5 times 0 minus 10 times 0 is less than 20. Well, 5 times 0 is 0. Negative 10 times 0 is 0. And 0 indeed is less than 20. To summarize, when you are graphing linear inequalities, if you have a less than or a greater than sign, make sure you used a dashed line. If it is less than or equal to, or greater than or equal to, use a straight line, solid line. If it is greater than or equals to, you feel great, shade above the line. If it's less than or equals to, shade below the line. To check your work, choose any point in the solution region. Thank you very much and have a great day.